Good morning all. Here we have a relay output board made by CNI. It is model UR_EIO/C S526. Now we're going to test this relay output board. So first we have to draw the circuit. I don't have any schematics of this board, so we're going to have to work it out. It comes on a DIN rail mount right there. Set that off to the side. Now I've already lifted up one side of this diagram right here that shows the normally open, normally closed, normally open contacts of the 8 relays. And the relay part number is G6RN-1 24 volts DC, manufactured by Omron. Now let's work out the circuit. Here's the back of the board right here. Here's the outputs, and this would be the inputs to the relay coils. That's real nice because I can see the traces right here. When I start drawing a schematic, I will work my way from the relay coil back. It just seems more intuitive that I start at the final destination and work my way back to the beginning. I don't know why it seems better that way, but it does. That's Omron. Now I won't draw all 8 circuits out. I don't need to do that. I can see that if I were to draw just one circuit, all the others would be the same. And I don't, in this case, I won't draw the relay outputs here to this connector. I have a diagram already set out for me. I don't have to draw that side. I just need to draw the relay side. So let's flip this over. I'm going to start on pin 1. This is a ribbon connector right here, and there's a diamond indicating pin 1 on the side of the connector housing. So this is pin 1. Here's pin 2, 3, 4, and they alternate back and forth. And this connector has 10 pins. So here is pin 1. Let's see where that goes to. Okay, so I've got the relay coil drawn in, along with its part number and manufacturer, and it's relay 1 on the board. And this one right here is relay 1, so we're going to come into this one over here. Put my meter in beep mode. Y'all can hear it beep when I have continuity. So here's pin 1 right here. There it is. It goes to this relay package right here. Put my meter in ohms mode, and we're going to measure what that relay is attached to here. Okay, so that's a 330 ohm resistor. Let's see if they're all 330 ohms. That's 330, 330, and 330. They're all 330, and it looks like I've got an LED in parallel with that 330 ohm resistor. Right here. So here's the 330 ohm resistor, And here is the LED. I'm going to have to look up inside to see who the positive post is. Some LEDs, not all of them, but some LEDs, the post is positive and the cup where the semiconductor lies is the cathode. And I can see the post on this side and the cup on this side. So this is more than likely the anode and this side's the cathode. And the anode, get back in beep mode, the anode goes to pin 1. So the cathode, I can see a trace here, goes to the coil. Let's draw that in. Here's the cathode of the LED. Here's the anode. It goes to pin 1 of the ribbon connector. I'm running off the board. I gotta pull this back a little bit. Okay. Are y'all still in there? There we go. This is our LED. And it's LED 1. Here's the parallel 330 ohm resistor. All right. That's N1. This looks like pin 2. And this is pin 1 of the single inline resistor right there. Now, every other, I'm going to set this off to the side, every other relay is going to be an identical circuit. So I'm not going to draw those out. Now, in order to energize this relay and turn on this LED at the same time, I have to put a positive voltage on the anode and ground the negative voltage on the cathode. So that means that I put, it's a 24 volt relay, I put 24 volts into pin 1, positive, it flows through the LED, turns it on, and then flows through the coil of the relay and turns it on. But in order to turn it on, we have to ground, since we're putting positive here, we have to ground this side here. So this side is going to go to ground back at this connector somehow. We'll find that in a little bit. We'll get there. So there's one circuit. Let's look at the connector here. Here's the other side of the coil. This is the positive side of the coil. So this is the ground side of the coil, and it comes to the 10-pin ribbon cable. It looks like on pins 9 and 10. So 9 and 10 is going to be our ground. Now, just to indicate where the other inputs to the relays are, I'm going to draw the other pins, connectors. There's 1, 2, 3, 4, 5, 6, 7, 8, and 9 and 10 are ground. these in. I'm pretty sure I'm getting off the screen there. This one goes to relay 2. Oops, RL2, not R2. This one will go to relay 3, relay 4, relay 5, relay 6, relay 7, and the last one, relay 8. There we are. Now, let me back the camera up. There's our complete drawing right there. Like I said before, you only have to draw one of these out because the other 7 circuits are identical. The reason they're identical is they all perform the same function. Let's go ahead and test it. I'll put 24 volt DC ground from an external power supply on 9 or 10, they're tied together. And I'll put plus 24 into 1 through 8, and then I'll test the relay contacts when I energize and de-energize each individual relay. Alright, I got my meter set to ohms mode. This green wire I'm going to put on pin 10, 9 and 10 is ground, and this yellow wire I'm going to use to turn the relays on and off. Let's see how it works. Okay, I can hear that relay clicking, and this LED 1 is turning on. There's pin 2. I can hear relay 2 turn on, and LED 2 is turning on. Here's 3, 4, 5, 6, 7, and 8. All relays energized and de-energized, and all LEDs turned on and off. So now I'm going to energize relay 1, and normally closed is on pins, these 2 pins right here, and normally open is on these 2 pins right here. And we have 0.2 ohms. So we have good continuity from those 2 pins right there with the relay energized. The 0.2 ohms is my meter lead. So if you subtract that 0.2 ohms from our reading through the relay contacts, we would have 0 ohms. Let's de-energize, and we'll check the normally closed contacts. And those are good. I have 0.2 ohms on the meter. Let's go to the second relay. This is the same. We have normally open contacts here and normally closed contacts there. So let's check the normally open. That's good with the relay energized. We have 0.2 ohms. Now let's go check the normally closed. 0.2 ohms, that's good. Now the third relay just has one set of normally open contacts, the same with relay 4, relay 5, and relay 6. So let's first check to see if they're open. Relay 3 is open. Let's energize that relay. Now relay 3 is closed. We have 0.2 ohms in the meter. Let's go to relay 4. That's open. We'll energize relay 4. Now the contacts are closed. Good. Let's go to relay 5. That's open. Energize relay 5. Now the contacts are closed. That's good. Relay 6 is open. Now with it energized, relay 6 is closed. Nice. Now we're back to 2 relays, 7 and 8, that are normally closed contacts and normally open. Let's check the normally closed contact first. That's good. We'll energize relay 7. Normally closed contact is open. Oops, on the wrong contacts. Okay, here we go. Normally closed is open on relay 7. And normally open is closed on relay 7. That's good. Let's go check the last one, relay 8. Normally closed is closed. And normally open is open. Let's energize it. Now the normally closed is open. And the normally open is closed with that relay energized. There we go. Wasn't that easy? Hardest part was mapping the circuit out. Okay. Nice. Nice. That's a good relay output board right there. There we go. All right, folks. I'll put that back in the DIN rail mount and we'll let her fly. Turn that 24 volts power supply off. There's that side. There's that side right there. And we're done. That didn't take long at all, did it? Nice. There you go. Hope y'all's having a good day. We're not doing too bad here. Let's go on to the next job. Have a good day, all. We'll see you next time.